Science for Quarter 3, Week 5. Describing motion using distance versus time graphs. Matatag Curriculum, Bansang Makabata, Batang Makabansa, with me, Teacher KMT. Good day, kids! Today, we will learn about describing motion using distance versus time graphs. Here are the possible objectives for today's lesson. Number 1. Construct a simple distance versus time graph. Number 2. Identify if an object is stationary or moving at a uniform speed using the line graph. Short review. Can you define the following words? Let's define them. Number 1. Distance. Describes the length of the path traveled by a person or object from the initial position to the final position. Describes how far a moving object or person has traveled. Number 2. Motion is the change in position from a reference point. Number 3. Speed describes how fast or slow an object or person has traveled. Number 4. Position, a place or point where something or someone is located or has been placed in relation to other things. Number 5. Time travel. It means time can move differently for objects moving very fast or in strong gravity. Have you ever wondered how we can show whether a car is going faster or slower even without watching it move? Imagine you are racing your friend on your bikes. How can you tell who's getting further ahead without constantly looking back? Today, we're going to learn a special trick to track how far something travels over time. This trick will let us create a picture called a graph that shows us exactly how fast and slow things are moving, even if we only see them at the beginning and end. Unlocking content area vocabulary. Number 1. Title. It describes the content or purpose of the graph. Number 2. Axis. The line graph contains two axes. Example, the x-axis or horizontal and y-axis or vertical. The x-axis typically represents the independent variable or the time, while the y-axis represents the dependent variable or the distance. Number 3. Labels. The name given to the x-axis and y-axis. Number 4. Line. It is the line segment that is used to connect two or more data points. Can you think of a time when you had traveled somewhere? How far was it? And how long did it take? Let us review distance and time. Distance is the amount of space between 2 points, while time is the duration it takes to cover that distance. Can you answer? How can we represent the journey from home to school on a paper? What information do we need? Good job! represent our journey from home to school on a paper, we need to know the distance and time it takes. Then, we can draw a graph with time on the horizontal axis and distance on the vertical axis, plotting points to show how far we travel over time. Storytelling. Imagine you're watching a race. Cars zip across the track, creating a blur of color and speed. But how do you truly know who is winning? What if we could capture the excitement of the race not just in snapshots but in a story of movement? That's exactly what line graphs do for motion. Think of each car in the race as a dot on a line. As time ticks by, those dots trace their journey across the graph, revealing secrets about their speed, distance, and even how they change pace. It's like painting a picture of the race with numbers, a language that unblocks the mysteries of motion. So why are line graphs so important in understanding motion? Very good! They make the invisible visible, and they tell stories of motion. A line graph is a unique type of graph that is commonly used in science. It is particularly useful for displaying trends and changes over a continuous interval or period. Before making our first line graph, let us first know its parts. Number 1 is the title. It describes the content or purpose of the graph. Number 2, axes. The line graph contains two axes, the x-axis or horizontal and the y-axis or the vertical. The x-axis typically represents the independent variable called time, while the y-axis represents the dependent variable called distance. In short, the horizontal axis or x-axis represents time. The vertical axis or y-axis represents distance.
Kids, remember, this is vertical line and this is horizontal line.
Number 3, labels. The name given to x-axis and y-axis. Number 4, line. It is the line segment that is used to connect two or more data points. Number 5, data point. A data point represents a specific value or measurement for a given variable at a particular point in time. Work example. This work example is to be guided by your actual teacher. This is how you will draw line graphs. First, label the axes. Second, determine the variables. Third, choose appropriate scales. Fourth, plot the points. Fifth, connect the points. Sixth, add title. Seventh, interpret the graph. And last, review and revise. What does the graph show us about the speed? Let us now know how to read the graph. Number 1, straight line. If the line is straight and sloping upwards, it means the object is moving at a constant speed. Number 2, flat line. A flat horizontal line means the object is not moving, it is at rest. Number 3, curved line. If the line curves upwards, the object is accelerating or speeding up. If it curves downwards, the object is decelerating or slowing down. Examples: constant speed. Imagine you're riding your bike at a steady pace. On the graph, this will be a straight diagonal line going up. At rest or stationary. If you stop to take a break, the line on the graph would be flat. Speeding up. If you start pedaling faster, the line will curve upwards. Slowing down. If you slow down, the line would curve downwards. Now let us try to interpret the graph. This is the distance or y-axis. This is the time or x-axis. Now this is fast, steady speed. Then this is steady speed but not fast because it went at rest or stationary. Because of it, it is now returning to start. Moving on to the next line, this means getting faster. Imagine this is a friendly competition. What color do you think will win in the first place? Very good. The color blue, which is fast, steady speed. Let us now proceed to lesson activity. Graph it. Meet Turbo Turtle. He is not your average turtle. Today is the Great Reef Race and Turbo is determined to prove he's the fastest underwater swimmer in his class. He sets off from the starting line, zipping through the coral tunnels and seaweed forests. But watch out for Mr. Stingray, who likes to zoom past and splash Turbo with his tail. Here are the data. Now, graph Turbo's data and describe his motion throughout the race. Now let us answer. Let's make our own graph. We'll put the time, the distance, the data, red for Mr. Turbo, blue for Mr. Stingray, and the title, Distance versus Time Graph for Turbo and Mr. Stingray's Race. If we are going to analyze the data, we will see that Turbo and Mr. Stingray both have the same speed during 15 meters distance. Yet, Mr. Stingray splashes Turbo during the 10 meters distance, making Turbo lose his goggles. Now, during the 3 minutes of the race, Turbo realizes his goggles are gone, so he goes back to find them. Now, Turbo finds his goggles. But Mr. Stingray is now leading and finished the race with an official time of 5 minutes. While Turbo finished the race with an official time of 7 minutes. Now let's answer. Number 1. What does the graph show about Turbo's speed at the beginning? Correct. Turbo starts the race at the same speed as Mr. Stingray. They both move at a steady pace. Number 2. What happens to the line at 3 minutes? Good job! At 3 minutes, Turbo stops moving forward because he realizes his goggles are gone and stops to look for them. Number 3. Does Turbo ever catch up to his classmates? Very good! No, Turbo does not catch up. Mr. Stingray finishes the race first and Turbo finishes later because he had to go back to find his goggles. Learners' takeaways. In a sheet of paper, write and arrange the steps in making a simple line graph. Let's answer. Number 1, label the axes. Number 2, determine the variables. Number 3, choose appropriate scales. Number 4, plot the points. Number 5, connect the points. Number 6, add title. Number 7, interpret the graph. And number 8, review and revise. Evaluating learning. Examine the distance versus time graphs below and identify which one of them is stationary, moving at a constant speed, or going back. Are you ready? Let's try to answer number 1. Is it a stationary, moving at a constant speed, or going back? Correct. It is going back. Number 2. Is it a stationary, moving at a constant speed, or going back? Good job! Stationary. Number 3. Is it a stationary, moving at a constant speed, or going back? Very good! Moving at a constant speed. Well done, kids! What have we learned today? Today, we learn about that a distance is the amount of space between 2 points. Time is the duration it takes to cover that distance. A line graph is a unique type of graph that is commonly used in science. It is particularly useful for displaying trends and changes over a continuous interval or period. What does the graph show us about the speed? Reading the graph. Number 1, straight line. If the line is straight and sloping upwards, It means the object is moving at a constant speed. Number 2, flat line. A flat horizontal line means the object is not moving, it is at rest. Number 3, curved line. If the line curves upwards, the object is accelerating or speeding up. If it curves downwards, the object is decelerating or slowing down. Steps in making a simple line graph. First, label the axes. Second, determine the variables. Third, choose appropriate scales. Fourth, plot the points. Fifth, connect the points. Sixth, add title. Seventh, interpret the graph. And eighth, review and revise. Kids, thank you for listening. I hope you have learned. Please do not forget to click the like, share, and subscribe.